In this video, we're going to talk about the basics of solving an optimization problem, and we'll do several geometric examples. So when we're talking about an optimization problem, we're talking about maximizing or minimizing some value. And this is a very large portion of your Calculus 1 class is using calculus to solve optimization problems. But in order to do that, you have to know how to set these up. So we're going to practice doing that. We're going to then solve our answers with just a calculator, but once you get to calculus, you'll be able to use calculus techniques to solve these. So a couple of things we want to do. First, we need to identify what we're trying to maximize or minimize. This is what we call our objective function. And then we have constraints, things that will constrain what we're allowed to do, algebraic constraints. Then we want to find that objective function in one variable. We usually do that by using the constraints. We also want to identify our interval of interest, and then we want to use algebra or technology to solve. For the most part, we'll use technology here, and then we're going to answer in a sentence. So first of all, for this first example, of all rectangles of area 100, which one has a minimum perimeter? So what you're trying to do here, your objective, and I recommend writing this out, your objective is to minimize the perimeter. And we know that perimeter is 2 lengths plus 2 widths. Since this is an geometric situation, I'm going to draw my rectangle, and I'll call this width, and I'll call this length. My constraint, what am I constrained by, is that the area, which in this case would be W times L, has to be 100. Now we want this objective function in terms of either L or W, but not both. So I'm going to take this here and I'm going to solve for W and get 100 over L. And I now have the perimeter is 2L plus 2 times 100 over L. And I have a function in terms of just one variable. So that's going to be 2L plus 200 over L. At this point, we can graph this. It happens to look something like this. We want to find the minimum point. So how do we do that using our technology? So once we have this graphed, so we're going to put this into Y1, and we'll graph it. And I want to find the lowest point on the graph. So I'm going to do second calculate. I'm going to choose minimum. And then it's going to ask me for a left bound, a right bound, and then a guess. So in this particular case, we get W equals 10. Well, actually, it will say X equals 10 and Y equals 40. But keep in mind that for us, that's a W and a P. So the minimum perimeter, the rectangle with dimensions 10, so that's 10 for the width, and then the length is 100 divided by 10, so 10 by 10 will have minimum perimeter. Let's take a look at another example. This is also a geometric example. Find the point P on the curve the curve is y equals x squared. I do not know why these are not coming across. That's closest to the point 18, 0. And what is that distance? So in this particular case, I'm going to draw this so I understand what's going on. We have y equals x squared, which is a standard parabola, and we have the point 18, 0. And what we're trying to do is minimize this distance. So this ordered pair is 18, 0, and this ordered pair is just some general ordered pair x, y. And we want to minimize the distance, and the distance formula is x2 minus x1 squared plus y2 minus y1 squared. And so for us, that's going to be x minus 18 squared plus y minus 0 squared. That has too many variables, so we're going to use the fact that y is equal to x squared. That's our constraint. And so we'll have a distance is x minus 18 squared plus x squared squared. If we graph this, and in this particular case, you're going to have to zoom out a bit, but it should look something like this. And this here is about 20. So you can go from negative 20 to 20, and then maybe from 10 in the x direction to 50 would give you a good way to look at that. And again, you're looking for this minimum point, so we'll do the same thing. Second, calculate, left bound, right bound, and guess. And you should get x is 2 and y is 16.5. So keep in mind, again, this is our distance as a function of x. So if x is 2, the distance is 16.5. And we want to know what is the point. So the point is x is 2. And if you plug 2 in here, you get y is 4. And the minimum distance is 16.5. We'll pick up some more examples on the next video.